Okay, hi everyone. In this video, we're going to have a review of lines. It's going to help you with the next section we've been working on for correlation, or the relationship between two different variables. So we're going to start with a graph, which many of you may notice from 097, recognized from 097. And what we have here are our two different variables. So let's say in this problem, x is going to represent time and y is going to represent distance. So I am, in this example, walking, okay? And I've plotted a couple of points here. So what is a point? A point is an ordered pair. It's a relationship. It's like think of it as a person. So at this point here, this very first point, I'm at time 0, right here, time 0, and I'm up here at miles 4. So when I start walking, time 0, let's say I'm 4 miles, I don't know, away from my house. So at time 0, I'm starting out 4 miles away. Now notice here, after 1 hour, so I'm over to 1 here now, I'm up here at 4, 5, 6. I'm up here at 6. So this is over 4. Sorry, undo that. I'm sorry, at time 1, after 1 hour, I've now walked, I'm 6 miles away from home. So after 1 hour, I am now 6 miles away from home. And then looking at this next point, I'm walking steadily along at a constant rate. After 2 hours, I am now 6, 7, I'm up to 8 miles away from home. So now I've got this ordered pair of after 2 hours. Oops, after 2 hours, come on, pen. Okay, take this out now. Okay, after 2 hours, I'm 8 miles from home. And what you can see here is if I connect these dots, I've got myself a straight line, or as straight as I can do, and I can continue on this way and walk all day. And so after 3 hours, how far am I away from home? So the idea with a line is that your pace or your rate or whatever it is you're looking at is always constant. The change is constant. You've got a constant change. All right. So what does this mean? Well, this is what we call the steepness or the slope of our line. All right, and the slope is equal to that change in y, that's what that delta means, over the change in x. Or maybe some of you remember the formula y2 minus y1 over x2 minus x1. And what does that mean? Well, it means, let me take another color here. It means if I'm starting here, how far do I go over and how far do I go up? So, for example, from this first starting point, to get to the next point, I went over by 1 hour. After 1 hour, I've walked how many miles? I've walked 2 miles. I've gone from mile 4 to mile 6. So in 1 hour, I've gone 2 miles. After another hour, I've gone another 2 miles. And so on. After another hour, I've gone another 2 miles. So I'm walking at a steady pace. What is that pace? Well, that pace is my slope. So another way, if you don't, you can count on your graph, or you can also go back over here to your ordered pairs. So all I need are 2 points, even though I've got 3 here. I'm going to use these two. Let's say I use ordered pair 1, 6 and the ordered pair 2, 8. All right, so this is like my x1 and y1, and this will be my x2 and my y2. So if I plug that into the formula, then I have 8 minus the 6 divided by the 2 minus the 1. 8 minus 6 is 2, and 2 minus 1 is 1. And as you remember, your y variable is time, or distance, miles, and your x variable is your hours. So in other words, what does this 2 miles per hour mean? 2 miles per hour is how fast I'm walking. Walking 2 miles per hour, and that's what we call the slope or the rate of change. Or sometimes, as you may remember, we use the letter m to denote slope. Okay? We're going to take this one step further and come up with the equation of this line. In other words, what's happening here? How can we, this blue line here, how can we write it as an equation? What is this relationship between every single x and every single y? There's a relationship between them. What is it? Well, the first thing we want to do is think about our explanatory variable, which is going to be x, or think of it as your independent variable, and y is your response variable. So this is response, and this is the explanatory. And so I have an explanation of that, and there's another video that talks about response and explanatory and what they mean. But really, whenever you're looking at your response or your dependent variable, you're talking about which one is affected by the other. So in other words, the amount of time that passed is affecting how far I've walked. All right, so we've got a relationship between x and y. So every y is going to equal something is going on with this x. Well, what are we doing? We are going to multiply the x variable by the slope, and we have to add to it whatever that starting point was. So maybe this formula looks very familiar to you. It is a relationship between every y and every x. And what these m and b, which are constant, m is your slope, and b works out to be what we call the y-intercept, or in other words, your starting point. Where were you on the y-axis when you started at time 0? Where were you? So for this equation of this line, we would end up with y equals, my slope is 2 miles per hour, plus I started at this point right here. I started at 0, 4, so we use the letter 4 just denotes what y was when x was 0. That's what we call the intercept. So this is the equation of the line. It's the equation of the line. And we can use this line to predict other things. So for example, where will I be if I walk for 7 hours? How far from home will I be? How far from home will I be if I walk for 7 hours? Well, I could keep going here. I could go out to 3, 4, 5, 6, 7. I could go, and where is this point? How far up is it? Or what I could do is I could keep using the slope. I could go for every 1 I go over, I'm going up 2 over 1, up 2 over 1, up 2, until I get out here to the 7, right? And the question then becomes, what's this point here? Or actually, I know the 7 is here. What is the y that goes with it? I know it's going to be on this line because I haven't changed my pace. So I could count 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's 18 up here. So 7, 18. Would I have gone 18 miles? Well, let's check. Let's plug it into the equation. So I'm going to go down here. I'll use a different color. So y equals 2. And so the slope and the intercept never change. I want to figure out what pair, what ordered pair, what partner goes with x when x is 7, or after 7 hours, how far have I walked? Well, 2 times 7 is 14, plus 4 equals 18. So yes, in fact, after 7 hours, I will have walked 18 hours. Okay? And that's just a review of lines, and lines have meaning. Okay? There's a relationship between your x coordinate and your y coordinate, and this will tie in with what we're doing with in correlation and figuring out lines of regressions. But I wanted to have a little bit of a review of what a slope is and what a y-intercept is. And as you move forward, one thing is important to keep in mind. The equation of a line is in fact y equals mx plus b, and that's when you have a straight line, really in any direction. This would be, you could have a line that goes this way and so on. This would be a slope that is negative, and this is a slope that's kind of steep. This yellow one would be a slope that is positive, and so on. Now, when you get into correlation and statistics, we write this formula a little differently. We write it a little differently, but it's really the same idea. It just means our responsive variable, or y, is equal to, and we switch the y-intercept, b plus, and then the slope becomes an a. X. So you're going to just see this change, but really M is it's still the same formula. This is still your slope, and this is still your y-intercept, okay? But now when you have it in this form, what that means is that you have a relationship between two variables, and you're plotting them, and you've got all these different, but they're not necessarily perfectly linear. They're up here, everything falls on the exact same line. But if they don't, and you see this, we've been working on this in previous videos, you end up with a correlation coefficient. Up here, your correlation is equal to 1. Here, your correlation is equal to -1. But what happens when it's not perfect? Let's say you have a R equals 0.8 or something like that. What this formula here is what we call the line of regression. And it's still, we have a formula for getting to it. Or another way of thinking of it is a line of best fit. What is the closest line that sort of representative of all these data points? You know, some line that sort of minimizes the distance, the overall distance of these points from it, okay? And that's what we call the line of regression. And that line of regression will have an equation. It doesn't mean every point is on it. It just is representative of the closest relationship between your explanatory variable and your response variable. And that equation will come out as y with a hat over it equals b plus ax. So just practice some of those problems that we've been doing in the homework. Okay, good luck.